everyone, I'm Heidi Postle. Welcome back to A+ Maths. Today I'd like to continue on from our functions where we did straight lines and parabolas, and today we're going to do cubics and exponentials. Let's get started. Let's take a look at some cubic graphs now. They're a little bit different to our normal straight line and our parabola. These ones have a little bit of a wiggle. You've probably already seen them in class. Our basic graphs are y equals x cubed, which looks like this, and y equals minus x cubed, which goes the other way and looks like that. Remember, everything's based on our basic curves. So if you're having trouble, those are the graphs you need to know first. That's where we're going to start everything from. Let's have a look at y equals x cubed plus 1. We're going to do them the same way that we did the quadratics. What is our basic curve here? Our basic curve here is y equals x cubed. And then it's plus 1. And the plus 1 tells us to go up 1. Same thing as before. We're going to draw our basic cube. What does y equals x cubed look like? Like this. Now we need to take this whole graph and move it up 1. And hopefully you get this graph. And of course, highlight your answer or rub the other one out. Remember that the other one is working, so it's always good to keep your working. What if we have something attached to the x like this one? Y equals 3x cubed minus 2. Again, our basic curve is y equals 3x cubed. Because what does the 3 in the front tell us? It's just like a straight line. The number in the front just makes everything steeper. Makes it go up much faster. And then we have our minus 2, which tells us that the whole graph needs to go down 2. Hopefully you're starting to see what's happening and that the graphs are starting to become more doable. So we have our basic graph for y equals x cubed, but this one's going to be a bit steeper because of the 3 in the front. And now we need to move the whole graph down 2. And that's what we're left with. What if we have y equals minus x cubed plus 1 this time? Again, we have our basic graph, which is y equals minus x cubed. And then we have our plus 1, where the graph goes up 1. So of course, we're going to start with our basic graph of y equals minus x cubed. Hopefully you all know what that looks like. Y equals minus x cubed. And then that graph has to go up 1. Good. And that's it. You starting to get the hang of it now? What if we have something attached to the x like this one? Y equals minus x minus 2 all cubed plus 1. So we know, firstly, that it's a minus x cubed. And the minus tells us that it goes in that direction. Then we have x minus 2 all cubed. So this time there's something attached to the x. And when there's something attached to the x, what does that mean again? It means that it moves it left or right. This time it's a minus 2, so we know that it's moving to the right 2, just like it did in quadratics. And the plus 1 at the end means the whole thing goes up 1. Great. Are you starting to see how it's all sort of the same? Let's see if we can draw it. We draw our basic graph, y equals minus x cubed. We now need to move this graph over to the right 2. And then we need to move the whole thing up 1. And highlight your answer. That wasn't so bad, was it? It looks a lot more complicated than what it actually is. Try to split it up and keep everything simple. Draw your x cubed plus or minus x cubed, move it to the right, move it up or down. Don't try to do everything in one go. Split it up and do it bit by bit. Y equals 2 bracket x plus 1 all cubed minus 2. Remember that the number at the front just makes the whole thing steeper. So here we have our basic x cubed. It's positive. But we know that it's got something attached to the x. It's a plus 1. That's going to move it to the left 1. And then our minus 2 at the end moves it down 2. So we have our basic x cubed, which looks like this. That's going to be a little bit steeper than usual. We know that it's going to move to the left 1. And then it's going to go down 2. And I can highlight my answer. We now want to take a look at exponential graphs. When do we use exponential graphs? Exponential graphs are used in many different places in the real world. Computer games is the most common one for most of you, I would imagine. Now, computer games use game physics engines to calculate the movement and the geometry involved in the game. It's all very complicated, but the games use algebra that involve exponentials in their formulas. If the maths isn't correct, then the game doesn't work like you expect it to. There are lots of people in the world who use exponentials with their work, such as economists, bankers, financial advisors, insurance risk assessors, biologists, engineers, computer programmers, chemists, physicists, sound engineers, statisticians, mathematicians, geologists, and lots more. So don't think it's just graphs and numbers on a piece of paper. Many people actually use this for their jobs in real life. The most recent example of exponential growth would be of the COVID-19 virus. Take a look at this graph, which shows the growth of COVID-19 cases in Australia, which is clearly an exponential graph. Now we can take a look at exponential graphs. Exponential graphs always have x as a power. So we have y equals 2 to the x, and we would have y equals 2 to the minus x. They're going to be our basic curves, and they look like this. This one is y equals 2 to the x, and y equals 2 to the minus x will go in the other direction, like this. You have to be careful with exponentials because you have to know that they have an asymptote. If you have anything to the power of something, it can never be something negative. The answer will never be a negative number. So 2 to the power of x and 2 to the power of minus x will have what's called a horizontal asymptote at y equals 0, because those graphs will never ever go past those lines. And you draw those in with a dotted line and you must label them. So now let's say we have y equals 5 to the power of x plus 1. Well, 5 to the power of x is our basic curve. Remember, the 5 just makes everything steeper, like 2 to the x, now it's 5 to the x. And the plus 1 means the whole graph just has to go up 1. Well, that's normal, isn't it? So let's have a look. Here we have our normal graph, y equals 5 to the x. It looks the same as 2 to the x, except it'll be much steeper. Don't forget to put your asymptote along y equals 0. You can see the dotted line there on the x-axis. Now, this whole graph has to go up 1. What you have to be careful of here is that when you move a graph with an asymptote, the asymptote needs to move as well. So when you move the whole graph up 1, the asymptote goes up 1 as well. And this is what you're left with. Don't forget to label your asymptote, y equals 1. Let's have a look. Y equals 3 to the power of x minus 2. Here we have our basic curve is y equals 3 to the power of x. And then we're taking it down 2. Minus 2 is down 2. What do we do first? We draw our basic curve. Great. Hope you can all do that. So we have y equals 3 to the x, which will look like this. Don't forget to label your asymptote, which is y equals 0 along the x-axis. See the dotted line? Now we have to move the whole graph down 2. And remember that when you move a graph with an asymptote, the asymptote must go down as well. So your whole graph goes down 2 and the asymptote moves to y equals minus 2. And don't forget to label it. Let's say we have a negative power. Y equals 3 to the power of minus x plus 1. So what's the first thing that we need to draw? We need to draw y equals 3 to the power of minus x. And that's our basic shape. 3 to the power of minus x. Looks like that. Now, don't forget you have an asymptote at y equals 0. Now, the whole graph has to go up 1. So you move the whole graph up 1, and don't forget to move the asymptote with it. The asymptote has to go up 1 as well. And you can highlight your answer. Let's have a look at another one. Y equals 3 to the power of x minus 2 plus 1. Now we have our basic graph, which is 3 to the power of x, with a minus 2 attached to it. So what does the -2 tell us? Good. It tells us that we need to move the whole graph to the right 2. And then we have +1, and the +1 tells us the whole graph goes up 1. So let's start. Remember, doing it slowly but surely, bit by bit. We're going to start by drawing our basic curve of y equals 3 to the power of x. Don't forget the 3 just makes it a little bit steeper. So we've got 3 to the power of x. Great. Now we need to move the whole graph to the right 2. So you just move it to the right 2. It actually stays the same. It looks the same, but it's moved over to the right. And then we have to move the whole graph up 1. And don't forget, when you move the whole graph up 1, don't forget to take the asymptote with it. So you have a new asymptote of y equals 1. Make sure you've labelled your asymptote. That's very important. All right, let's try y equals 3 to the power of -x minus 1 minus 1. Now this one's a little bit trickier because you've got the minus in front of the x, which we really shouldn't have. So we're going to first factorize out the minus from the power. And then we get y equals 3 to the power of minus, open brackets, x plus 1, close brackets, and then your -1 stays out the front. So what have we got? We've got our basic curve, which is y equals 3 to the power of minus your x now, but the x has a +1 attached to it, which means that it moves to the left 1. And then the -1 takes the whole graph down 1. Now let's try and graph it. Now that we've understood each section, let's graph it. You first start with y equals 3 to the minus x. Then you want to move the graph to the left 1. And then we move the whole thing, including the asymptote, down 1. And don't forget to label your asymptote y equals -1. I hope you enjoyed the lesson. See you next time. Don't forget to like and subscribe. Bye!